Hey guys, welcome back to Rocket Gyan, my fellow space tubers, and today I'm very excited because we are gonna see a sounding rocket launch, and this one is like massive because it is carrying around 126 experiments in just one go and in just one sounding rocket. So it would be like very, I haven't seen this much experiments in just one rocket, so it would be great to see how it spans out. But right now we are t minus 26 minutes from the launch. If everything is good, weather cooperates, then you'll see the launch from the West Virginia Wallops facility, and this rocket will be going up to the sky, although it is 5:30 a.m. In the morning for people in the US, so I can understand your frustration, but uh, it's all right. It's good. You will actually have some great treat when this rocket lifts off. So welcome to this stream, all of you. Welcome, Pat. How are you? And let's just jump into it and see what this rocket is all about. So this rocket which you are seeing in front of you is called as Terrier-Improved Orion, which means there is a Terrier first stage, okay, and then a improved Orion second stage, and then the payload bay. So this one is a unique one because here not only the experiments will go to the space, but also we'll be able to recover it from the ocean. So we'll see how everything looks like. But this rocket is a spin stabilized rocket, which you can see improved Orion stage is here and the Terrier is here, and this one is like a much more detailed one. So this rocket is capable of putting payloads from 200 to 800 pounds, and capable of achieving altitude of around 200 kilometers, 80 kilometers to 200 kilometers depending on the payload size. So this is that, and this one uses Mark 70 motor, which is a Terrier motor here in the first stage, and it has a cruciform tail fins, and also it uses a spin stabilized configuration, which means it is able to stabilize itself because the rocket does not have any thrust vector control, which means steering capabilities. Therefore it is not it can't change its direction to correct its trajectory if anything goes wrong. So therefore it uses a very unique configuration by using spin stabilized. Spin stabilized is nothing but, there is a top, spinning top is there, right? When it is simply resting, it just tumbles down, and it is not resting on the tip. But when it is spinning, it is very stable and it can rest on the tip, right? So that is the same principle which is followed here. When it is spinning, it is stable, therefore it does not go here and there when it is intended to go to its trajectory. So also the first stage has a bipropellant phase motor, which means in 4 seconds it produces around 85,000 newtons of thrust, and then it tails off to approximately 3,000 pounds until the burnout occurs. Sorry, no, this one is for improved Orion. Okay, so the first this is the improved Orion. So the first 4 seconds, 85,000 newtons of thrust, and then around 3,000 pounds of thrust is there until the burnout happens at 25 seconds. So and the fins of this one, the improved Orion, is made in such a way that at the time of burnout it is spinning at 4 cycles per second. Okay, so this is how it looks like. So this is where the clamps are here, and this is the first stage. This is the cruciform fins, the Orion stage payload, and here all the payloads are there. Recovery section is also there, in which some of the payload, as I said, will be recovered by a chute. So yeah, this is how it looks like. Now let's talk about this RockOn program. So this RockOn program is a very what should I say, a conventional program, and I really like it because it enables them to have interaction with the students, because this program is mainly focused on students from the school, universities and institutes so that they can participate in something related to space, and therefore can develop interest in it. And it's not like a, uh, they don't feel like we have the rockets and rocket science and space technology is like way out of their field. It's not like that. So this is their program. Here you can see literally the school students can also participate, and here you can see how it actually looks like. I really wanted you to see this one. This is a 2017 RockOn program. Like you will see how it looks like, how people assemble their rockets and sorry, the experiments in here, which you can see. You can see there's a plate. So this plate is very much necessary because this is the plate where all their things will be made, and experiments will be made and assembled. Here you can see this is what they are doing right now, all the experiments assembling on the plates, and there are multiple plates in one payload bay, okay, which you will see here. This is the testing going on. There you go. Multiple discs are there which is inserted in this payload bay, and this payload bays are also multiple. So that's how they are able to incorporate like 126 experiments in just one go, you can see. And then the if you'll see the rocket integration, this is how the rocket looks like. And as I said, a multiple payload bays are also there, which you can see in front of this, and each bay has its own disk, right? And then the testing happens and everything, integration testing happens. So, and this is how the payload bay is integrated with all the disks and everything. And this is the shield cover which just separates when it's in the space. So this is how the rocket and everything looks like. Okay, you can see this is the testing which is going on. Integration testing is very much necessary. Once it is integrated onto the payload bay, every experiment is tested whether it is performing as per the requirements. So here you can see now everything is done. Now it will be covered with this shield. There you go, then assembled. And there is also one thing that people who have made this rocket means these payloads sign on this payload pairing or whatever you wanna say. So that is also very nice. Like they're literally handwritten something goes into space. So yep, that is pretty much about this RockOn program. For this especially for this one, as I said, it will be carrying around 126 experiments, out of which 39 experiments which will measure acceleration, humidity, pressure, temperature, radiation counts from the RockOn program, 7 experiments in the RockSat-C program, and approximately 80 small cubes with experiments developed by middle school and high school students as part of the Cubes in the Space program. And it will fly to an altitude of around 73 miles. And yes, this is the record 208 participants this year. So this one has like too many participants, and that's why too many experiments. And the cubes in space, as I said, the RockSat-C participants and projects have cubes in space. And the Hobart and William Smith College will be measuring the wavelengths in different spectra like visible light, UV and thermal. Then old Dominion University will explore the practicality and accuracy of additive manufacturing while experiencing aggressive changes in gravitational forces explored in a sounding rocket program. And then the Temple University will implement a single bubble sonoluminescence, which means producing light from a sound experiment aboard payload to compare the change in illumination with respect to the change in gravity. So this one would be very interesting. And then the University of Delaware is there, which will measure the effects of high radiation exposure on high frequency components while simultaneously developing an open source project platform for future use within the RockSat community. So this is great, and like there are so many experiments I can just go on and go for. So yep, that is how it looks like. Now moving on, as I said, the payload bay, this is how it looks like, and it has like these many discs in it, and each disc have many experiments in it. So this is how it looks like. Now let's have a look at the mission profile. So the mission profile is this one. Obviously there is ignition happens at T0, then the end of Orion burn at T is equal to 0.6 minutes, which is around 30 how much 0.6 minutes, it is around 3 seconds to 4 seconds. And then the altitude will be reached here, and then okay, so this is a end of Orion burn, not that one, so it's 36 seconds. Yeah, T equal to 36 seconds, the second stage will also cut off, and the apogee will achieved at 73 miles and approximately T equal to 2.8 minutes. And then the chute will deploy at T equal to 5.5 minutes, and once the chute deploys, it takes around 10 minutes to coast and splash down to the ocean. So this is how everything would look like. This is the mission profile. Now let's have a look at your favorite part, which is this one, like how the rocket would look like, where you can see this rocket. So this rocket can be seen from here, equal to 10 seconds. The people from Lemont Atlantic will be able to see, and then T equal to 30 seconds, people from Crisfield, and you can just see it from here, and most of the people will be able to see the rocket from T equal to 60 seconds from Leicester, Salisbury, and Cambridge and whatnot, so Seaford. And you can see that the rocket at T equal to 60 seconds will be visible from all over here. So yeah, I think that is pretty much about it. Just switch over, and then have I hope you are able to hear, right? Okay. So yep, this is the live view of the rocket. We are T minus 40 minutes and 20 seconds remaining. Everything is looking good as per the launch.
High school students to put passive experiments on board the rocket, and this is conducted in conjunction with a partnership between Colorado Space Grant, iDoodle Learning, and also National Langley Research Center is involved in this program. So we were glad to also be able to have these students be able to fly with us today, or at least their experiment students won't be flying.
Obviously.
So the launch was originally planned for yesterday. However,
hey Daniel, how are you?
On Wednesday, we did experience a little payload issue, and so that got fixed Wednesday afternoon. But then it comes out that the weather was not really acceptable for launch. We had low clouds in the area yesterday with a little bit of rain, and also the seas in the recovery area were a little bit on the rough side, so it would have been difficult for us to send a boat out to recover the payload. So we did.
Marco, so regarding this geometry of the grains, I don't have much information, because this is like these I think are not very these motors which are used are not specifically designed for sounding rockets. Those were ICBMs, if I'm not wrong, previously. So we don't have much information on how this grain geometry is.
Arrow at our target. Once we ignite the rocket, we really don't have any control where it's going. So we adjust for the winds that you heard them talking about, flying to chaff balloons. It gives us the winds up above us, and that way we can point the rocket to make sure we can hit that target in space that we're looking at. We're looking to go about 72 miles altitude. Again, this is a very fast rocket. The rocket will clear the rail in about 0.4 seconds. The Terrier motor, the first stage motor, will burn out at 5.2 seconds. We then coast for about 10 seconds. Second stage Orion ignites at 15.
This is RSO, go ahead. Provide pad 250K launcher preliminary wind-weighted settings.
Preliminary wind-weighted settings are as follows. Azimuth 126.1, elevation 83.2.
Right now they're adjusting the rocket orientation so that it hits the target. Because there is no guidance control in this one, there is no thrust vector control for the rockets because this is a solid rocket motor. So and a sounding one, so there is no thrust vector control or gimbling. So therefore they make sure they are very much accurate with the pointing of this rocket. And
That we hold at the 10-minute mark, where we have the point in the count to do so, and hold for 5 minutes.
okay, so we are holding in for at t minus 10 minutes for 5 minutes. That's what they have.
TD concurs. Programmer, you hold at 5.
Hold at
10.
5.
Hold at 10.
Copy.
Holding at 10.
50K launcher set to azimuth 126.1, elevation 83.2.
Copy, check 9-6.
And the reason for the hold, as he said, was the
And
weather
your hold
balloon.
will be holding at T minus 10-minute mark and allows to just to make sure that those winds are measured right, that we do have the rocket pointed in the right direction.
Hey, Remy G, you got a payload in this one. Good luck for your
Awesome.
team. I hope they'll be able to. You'll be able to get a good data on this one. So it is very exciting for you, right? Are we holding or not? Because the timer is still going on, but said they'll be
All
holding.
stations, this is TD. We're in a hold for about 5 minutes for wind waiting activities.
Okay, so due to weather, specifically due to wind,
Copy.
we are at hold at t minus 10 minutes. So I can say right now everything is not looking good because of the weather, but this rocket you will not disappoint you at all, because this is a very cool looking rocket when it lifts off. And oh boy, this is very really fast. You can't blink at t0 at all. If you blink, this will go up into the sky for like kilometers up to the sky. This rocket is really very fast.
Given the breakdown again for the launch today, the flight, that rocket will clear the rail at about 0.4 seconds after ignition. Terrier motor first stage burns out at 5.2 seconds. Second stage Orion then ignites at 15, and the improved Orion will then burn out at 40. The payload and the rocket will continue on. We're looking at a peak altitude of about 72 miles. Then the payload will come down by parachute, and expected to land in the Atlantic Ocean about 41 miles from Wallops. It will be picked up by one of our local boaters and then returned back here to Wallops. And expect that everything works out right. We should be having it back here around noon, and then the students that are here will receive their experiments, and they'll be able to start digging into them and see how things went.
RSO TD on 1.
All right, so go ahead.
Yeah, RSO, I'm going to instruct the programmer to pick the clock up at 0925 Zulu. Any issues with that?
I don't believe so. I think we should be good with that.
Okay. Let me know if something comes up.
We'll do. We're looking good.
Okay, so there you have, guys. I have made some animations to assist you for the
Programmer
launch.
TD on 1.
Go ahead.
Yes, sir. Can you pick up the clock at 0925 Zulu?
Copy that. 0925.
And so we'll be picking up the countdown here in about 3 minutes. Targeting a launch at 5:35 a.m. Eastern Time. This is a busy launch week for Wallops this weekend. And actually we have, in addition to the launch this morning from here at Wallops. We are targeting a possible launch this afternoon from Sweden with our balloon program. And then Sunday morning will be the launch of the first of 3 rockets that we have going from Australia this summer. Launch time in Australia will be at 9:14 a.m. Eastern Time, and that launch will also be streamed. You can watch that launch at the Equatorial Launch Australia's YouTube site beginning around 8:30 a.m. Eastern Time. That rocket will be launched from Arnhem Space Center in the Northern Territory of Australia.
Yep, Daniel, that's what I'm here for, to assist you with the live streams as best as I can. So this is and obviously for this sounding rocket especially, you need some sort of animations going on side by side. So here we are, and hopefully you will be able to see everything for this launch, and I hope this will be in sync with the mission profile, because the actual mission profile was not available.
About 30
So
seconds.
yeah, it was kind of rough. So guys, we are at a hold because of some wind activity, but we should be picking up the count in just 1 minute or so. And this rocket, let me just summarize this rocket once for you. Many people have joined. So this rocket is a 2-stage rocket, and both the stages are solid
10 minutes
motors.
counting.
Okay, there you go.
This is RSO, go ahead.
Can you provide the status of the impact area clearance?
Inward.
All right. So we, as I was saying, that this is a
We are
two-stage
good to go with impact area clearance.
spin stabilized rocket with a SRB in here, and by spin stabilized I mean this will be spinning. Yep.
In addition to the weather looking good, the avoidance areas downrange are also clear for launch today.
The range is green, the weather is holding up. That's what we want to hear, right? So yeah, this is a spin stabilized rocket, which means it will be spinning, literally spinning, and there are spin motors to assist that in the first stage. And although in the carbonized version there would be any spin, because it was difficult for me to control it while it was spinning, so I didn't have any spin in it, but you know, it will be spinning for the stability. And yes, this is carrying around 126 experiments from RockOn, RockSat-C, and the Cubes in Space program, which is like middle and high school in Cubes in Space, then the university students and the institutes and all those things.
Programmer,
Programmer green.
LWO,
LO green.
SCO,
SCO's green.
LC,
LC green.
PLC,
PLC green.
LPM,
LPM green.
MM,
MM green.
SRPO,
SRPO green.
RSO,
RSO green.
PM,
PM's green.
TD.
TD's green. All stations are responsible for reviewing the go, no-go criteria listed in the OD. Only stations annotated with an asterisk in the previous step are permitted to call hold. All other sites should report red. Check 101.
M&O PM 1. M&O PM channel 1.
Go ahead, PM.
Confirm timing switches for high-speed cameras are enabled.
Timing switches for high-speed cameras.
So
are
there you
enabled.
go, guys. We had the go no go poll, and everything is go for the launch. And it is very rare to see this sounding rocket launch in just without any big delay, because sounding rockets are meant for delays because of the winds and weather.
126.6.
So yeah, they are adjusting the launcher setting, but right now, yes, everything is green. The range is green, weather is holding up, payloads are ready, and rocket is set up to go into space. So let me just tell you, this rocket will go to 73 miles in altitude, and it will also be recovered. So there will be chute which will be deployed at t plus 5 minutes, and at t plus 15 minutes the splashdown will occur.
And this morning's launch is expected to be seen in the Wallops area, mainly eastern shore of Virginia, lower eastern shore of Maryland, and southern Delaware. Since this is one of our smaller rockets that we launch here at Wallops, and also we do have the sun coming up.
50K launcher settings are azimuth 126.6, elevation 83.1.
Copy, check 104.
And if you are watching the stream and expect to go out and try to catch the launch in the area, make sure you account for the time difference variance, and that usually you have about a 30 to 40 second time difference from the events that you see on the stream to those actually happen. So make sure you get out early to catch the launch.
Okay, Rising, I'll check my email. But right now, T minus 5 minutes remaining. Things are looking great, and yes, it is morning in there. Good morning to everyone, and it's a very nice day to see a rocket launch when you just wake up. And for you just
Coming
joining
up
in,
on T minus 5 minutes.
this is the mission visibility profile. So at t plus 10 seconds it will be visible for a very
5 minutes.
small
PLC check 106.
amount of people, but most of t plus 30 is the pink one, and the t plus 60 is the yellow one circle, and most of the people will be able to see it at t plus 60 seconds, but still it is not going too high and neither too far. That's why the visibility is not very wide. So if you want to see this, just head down to the launch side and see the rocket for yourself. Also guys, don't just have a look at the timer here, because there could be some delay in the stream. So at t minus 2 minutes or so, just go out there and start looking in for the rocket. So
And the vehicle is now on external power.
okay, t minus 4 minutes remaining. Hey Space Maniac Zach, how are you? Welcome to the stream. Top of the morning. I hate the waking up early, but yep, the rocket and my stream is a good combo, right? So yeah.
RSO, ROA. Provide pad 2 50K launcher final wind weighted settings.
There are no changes to settings. Final wind weighting settings are as follows. Azimuth 126.1, elevation 83.2.
PMRC, good 5 code.
Copy, I'll check 107.
RSO azimuth 126.1, elevation
Scratch
83.2.
that. Azimuth 126.6, elevation 83.2.
Copy.
83.1, excuse me. What is this written down?
Wow, okay.
LC, ROA.
He's not happy.
LC.
Verify 50K launcher final wind weighted settings are azimuth 126.6, elevation 83.1.
50K launcher is currently set. Azimuth 126.6, elevation 83.1.
Copy. Check 109.
Yes, Daniel, I tried to.
PLC check 110. PLC
The
check
syncing part is done previously beforehand only.
113.
So yeah, it would be very difficult to do it. Yeah, so yeah.
RCPM channel 1.
But the problem is we don't have a mission profile, a proper mission profile for this mission. So can't say for sure whether everything would be in sync.
On internal power, and
Check
the student
111.
experiments have been activated.
The vehicle is in internal power. The student payloads have been activated. 126 experiments ready to go. Rocket is set up. The launcher is just waiting for its command at T minus 2 minutes 4 seconds to go. Ignition, lift off, go to the sky.
2 minutes.
And please, guys, don't blink. Don't blink away when this rocket lifts off. This is a very, very fast rocket. and it will just clear this launch tower in just zero point 0.4 second, not even 1 second. Just is so fast. So don't you blink when this rocket lifts off. T minus 1 minute 30 seconds. Things are looking good. Weather holding up. Range green. Launcher is ready. There you go. Okay, I'm getting excited. This is the most fun part, right? The rocket launch, and especially the sounding one. T minus 60 seconds remaining. This is happening now.
check 117. Payload is go.
Payload is go. There you go. Vehicle is in internal power. It's just the silence before the storm. Okay, I'm excited. And all the best to everyone whose payload is on board right now. T minus 30 seconds.
Terrier armed.
Terrier armed. T minus 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 10,
9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Okay, ignition and liftoff. Whoa! Burnout.
Three is tracking the booster.
The first stage has burnout. The second stage has ignited. A bit off there, but yeah. Second stage has ignited. Will burn for around 25 seconds. So yeah, the mission profile was changed for this one. So that's why not in sync, but you can get an idea of what is happening right now.
18 and 5 are tracking the payload. Radar 3 is tracking the booster.
Plus 40.
The second stage has cut off right now. Now it will despin. Right now, not the despin. Despin won't happen right now, but the separation will happen first of all. Then you'll see the things happening. But right now, this is how the rocket looks like. God, I'm excited. Okay, so this is it. This was how it was supposed to be, and right now it is not burning. So you must be wondering like how is it still going up? So it's like when you throw a ball upwards, you don't apply the force constantly to it. You just apply force once and then it goes upwards, right? Because of its momentum. So this is the same which is happening. The force, the engine has stopped or the motor has stopped.
PMR, so are you going to want a balloon post-launch for analysis?
But still the rocket has momentum to go up, so it will go up to 73 miles in altitude, and once it reaches the apogee, it will, there you go, the separation
Need to right now.
happens of the payload bay, and
Copy, thank you.
the payloads are exposed to the space for the experimentation to happen. There you go, you can see right now. All the readings are being recorded. So Remiji, hopefully you are able to team, or Remis, I'm sorry for your pronunciation. There is anything wrong which I said, but yeah, I hope you are able to get some good readings out of this experiment. Inertia and momentum. Yep, Daniel, you are right. So it has reached the apogee. It should have reached the apogee by now. Now they are waiting. Now the rocket must, sorry, the payload section is just waiting for it to come down. So it's now coming down. So since it is not going to the orbits, it's just a sounding rocket launch. It will just go up and then come down. So it will not go in the orbit, right? So 73 miles in altitude, and now it is just coming down, and it will splash down in the Atlantic Ocean. But it is a controlled splashdown, which means there will be a parachute which will be deployed, so which you will see right now. And yeah, that's how it is.
And so this morning you did see a good launch this morning of the Terrier-Improved Orion with the RockOn, RockSat-C and Cubes in space student experiments.
Yep, Daniel, some sort of aesthetics are necessary. So yeah, T plus 4 minutes. You can see the rocket is coming. The payload bay is coming down into the Atlantic Ocean.
The parachutes are expected to deploy during the descent approximately 7.5 minutes after launch. Then again, the payload will descend, land in the Atlantic Ocean about 41 miles out, and we'll go out and pick those up with a local fisherman. We'll pick those up for us, bring us back to the docks at Chincoteague, and allow us to bring the experiments back here to Wallops for the students to receive their experiments later today.
Hey, Space Maniac, thanks for that. 499.
Launch time this morning was 5:35 a.m. Eastern Time. Next launch from Wallops won't be until August 9th, and that will be the RockSat-X, which is a continuation of our student programs. The rocket will be a Terrier-Improved Malamute, so it'll be a little bit larger than the one we flew today. It also will be an early morning launch. And the experiments in the RockSat-X program are a little bit more complex than those flown in the RockSat-C program, and that the students are also given a little bit more weight that they can use, and also their spacing that they're provided is a little bit larger. So
okay, thanks for the continuous coverage and the awesome KSP side by side. Thank you so much, Space Maniac Zach. Really appreciate it.
So again, the next sounding
for
rocket
that
launch
499.
for NASA
Thank you so much.
is actually this Sunday from Australia at the Arnhem Space Center, operated by the Equatorial Launch Australia, and that will be shown live, streamed live on the Equatorial Launch Australia's YouTube site, beginning at around 8:30 a.m. Eastern Time. Launch is scheduled for 9:14 a.m. Arnhem Space Center is about 13 and a half hours ahead of us, so it will be a nighttime launch in Australia.
Go ahead.
Are we free to lower the launcher?
Stand by.
SRPO TD.
SRPO.
Do you guys want to take any measurements of the launcher?
Standby 1.
So they are actually just asking whether they can just lower down this launch rail, basically. So that will happen, and yeah, VRT plus 7 minutes 30 seconds, and the splashdown will occur at around T plus 15 minutes. So guys, if you maybe Remiji will be able to tell us in a good way. So how this rocket, this payload bay is recovered and given to you? Do you have any idea, like how is it done? I know there are some recovery ships which would be.
Do you have an apogee?
Which would give you means which will do the job, but like how is it experiments are transported to you? because most of the times it is like they are just downloading the data when experiments are performed.
934.7
But when most of the time that is the case, but this time since it is being recovered, also I'm not so sure whether all the experiments are recovered, but yeah, most of the experiments are recovered.
Copy 371,934.7 feet.
Good readback.
SRPO copies, thanks.
Okay, plus 10 minutes.
So there you heard the apogee. So we're looking at about 371,934 feet, which is approximately 70 and a half miles altitude for our peak altitude for this flight, which is pretty close to what we predicted it would be.
Plus 10 minutes, and yep, they achieved the altitude which they desired to achieve, which means they were pretty accurate on their launcher settings. Although I must say this one was not a a science mission, so therefore I wasn't able to tell you with all the the payloads which are going in, but this was definitely a student one, so 136 experiments is just much for one sounding rocket. So yeah, is something.
And so that concludes today's coverage of the Terrier-Improved Orion rocket suborbital launch from Wallops, carrying the RockOn, RockSat-C and Cubes in Space student experiments. Again, next launch from Wallops will be the RockSat-X student experiments on a Terrier-Improved Malamute. Launch will be early morning again, just after sunrise on August the 9th. Thank you for joining us and have a good summer.
TDS or PO on 1.
Go for TD.
Yeah, you can lower the launcher.
TD copies.
Okay, so people, I think now they have cut off the stream, but right now T plus 12 minutes. Still, it is going in for the launch, so that is happening. But yeah, so I hope that will conclude the stream. But let's just see how the rocket will. This the payload will splash down, but T plus 12 minutes, T plus 15 minutes, its splashdown will occur for sure, and yes, right now everything is looking good. I hope everyone who was involved in this mission, from the payload makers, the students, and the children, to the actual rockets maker, they were able to achieve what they wanted. Everything went as per the plan, and yes, that sweet data is incoming now, and hopefully you will be able to analyze that and get your project done, right? You get that certificate in your resume. Okay, anytime now. Okay, so things are looking good. Although, talking about the next launch, the next launch is from the capstone mission of Rocket Lab, which is great. You know, that is a kind of sciencey mission. Okay, yeah, that is kind of a sciencey mission, and this is the first mission Rocket Lab is sending to Moon. So, since Rocket Lab is a small sat launcher, so it's a big deal for them to send something to the moon. And they're not stopping there, they will be sending something to Venus too. Just a small rocket, but still so capable, right? So, yeah, that is happening, and the splashdown is about to happen. And there you go. Done and dusted. Yes, this is how it looks, when the splashdown happens literally. uh, since the parachute is making that thing vertical, once it is splashed down, it does this maneuver kind of thing, which it just splashes down in that way, horizontal way. So yeah, uh, so yes, there you go. We had a successful liftoff of the Terrier-Improved Orion rocket. The RockOn mission, RockSat-C mission was a successful mission today, and we are looking forward to the next mission from the Wallops also in August 9. But for the recent one, we have a mission from Rocket Lab on 27th of June, so a couple of days from now, and then 30th June we have. 29th June we have one SpaceX, 30th June from ULA, and again on 30th June. Okay, so 30th June is a very busy day for space. So there are like 3 launches. Okay, 4 launches. Dude, 4 launches are scheduled for 30th of June. And if all of them happens, that would be a great record. Four of them, 4 of launches. And one of them is from Virgin Orbit and PSLV, ISRO. So that would be interesting one. So yeah, guys, thank you so much for tuning in. It was a pretty great liftoff as always, and yes, it was interesting to have you all around. So if we go here, if any one of you has uh, got some views of the rocket, the photos of videos, you can just tag me at Rocket Gyan. But we'll see if we have anything. Uh, okay. See, that is too quick. Just too quick. All right. Okay. I don't think so. People have. Yep. Since this was a early morning launch, so there was no. Okay. One of one of them has the picture for the first rocket launch that I was able to see in the person, and it did not disappoint. Well, the rocket launches does not disappoint at all, no matter when you see it, and no matter which rocket you see it. So, yeah, even a sounding rocket launch is not a disappointment. So yes, this was pretty much about it, guys. So we'll see you again on 27th of June with the capstone mission. And thank you so much for tuning in. How am I going to manage for that date? Well, this is what I do. So we'll have to wait and see if all those 4 launches happen in just one day. Well, that would be some marathon for me. So pray for me on that day. But yeah, we'll see how that pans out. But right now, yep, things are good. Okay. Thank you all for tuning in. And until then, this is Priyanshu Royala. You just saw Rocket Gun. Stay safe, stay healthy, and